Hello and welcome to section 1.5, exploring angle pairs. Okay, this right here came from the book, so you would be able to find this in your textbook as well. It just is describing some different types of angle pairs. Adjacent angles are basically just angles that are next to each other. So you could see from this picture, they're sharing a vertex and they're sharing a side. So they are two angles that are kind of connected to each other. Vertical angles are, one, incredibly important. That's why I put a little asterisk there. They are two angles whose sides are opposite rays. I think that's kind of confusing though. I just think of it more in terms of whenever you have two lines that intersect each other, you're going to have two sets of vertical angles. Sometimes people call them the bow tie angles because it sort of looks like a little bow tie or like a sideways bow tie if you look at it that way. Some people think vertex angles, angles that are in the V of these crossed lines, but these are really important because they create congruent angles. Complementary angles are just two angles whose measures have a sum of 90. So here, if this is 90 degrees, you know that these two angles obviously have to add up to 90. You don't necessarily know how much each angle is, but you do know that together they add up to 90. Or they just could be any two random angles out there somewhere that if you add their degree measure, it adds up to 90. Supplementary angles, same idea, only the angles, the measures of the angles add up to 180 degrees. I have another asterisk here. If you look carefully at this figure, a linear pair, and we'll get into that more later, but this is very important because it is going to be used very often as well, because you know every time you see a straight angle, that's 180 degrees. So the reason why linear pairs and vertical angles are so important is because a lot of time in doing this work, you need a place to start. So you either have to be given some kind of information, you have to be given some kind of a marking, you have to have some place to start. And vertical angles and linear pairs, they just are. You never have to be told something is a vertical angle. You never have to be told something is a linear pair. You can see it, recognize it, and then you know that you have a relationship. So vertical angles, again, congruent angles. So you can often start by setting two expressions equal to each other. Linear pairs add up to 180, so you can always set up an equation by adding the two expressions together or whatever you're given and setting them equal to 180 degrees. So just looking at some of these angle relationships in this figure here, if I list an angle that's complementary to angle 1, I have to try to figure out, what's actually going to go with angle 1 to add up to 90 degrees. So this is 90 right here. This is also 90. 1, that should actually be a 6. So complementary to angle 1 would be angle 6 because together they are making that 90-degree angle. I also have angle 3, a little bit more complicated, but 3 is a vertical angle with angle 6 because, again, if I look at the two lines that are creating those two angles, these are sort of there in the bow tie, in the vertexes, in the V's, however you want to think about it. So technically, angle 3 would also be complementary with angle 1 because it's congruent to angle 6. An angle that's congruent to angle 12 would be 14 because, again, right here I have two intersecting lines. Those are the angles in the vertex, so those are my congruent angles. An angle that is supplementary to angle 12. Well, if here's angle 12, supplementary is 180 degrees. I'm looking for any angle that's really a linear pair with angle 12. So angle 11, right here, 11 and 12 are making this straight angle here. 13 is also supplementary because 12 and 13 are making this straight angle here. Again, there's also 180 degrees in a semicircle, so if I sort of look at the idea of a semicircle, those two angles are in there. An angle that is congruent to angle 8 would be angle 10. again, because those are vertical angles. Here's my intersecting lines, and here are the angles that are there in the vertex. An angle supplementary to 14, much the same thing. If here's angle 14, angle 11 would be a supplement because there's a linear pair. Angle 13 would also be a supplement because there's another linear pair. An angle pair that is congruent to angle 2. So this is just a little bit more complicated. Angle 2 is 90 degrees. So an angle pair that would also be 90 degrees is right here, angle 3 plus 4. If I added these two angles together, I would get another 90 degrees. 1 plus 6 also equals that 90 degrees. An angle pair that is supplementary to angle 6, well, angle 6 is right here. So again, I'm looking at anything else that would help complete the straight angle that angle 6 is already a part of. So here's a straight line here. So if angle 6 is here, angle 1 plus angle 2, that sort of finishes off the 180 degrees. I could also look at this straight angle. And if angle 6 is right here, angle 5 plus angle 4 finishes off that 180 degrees. That's what's all forming that straight angle. So again, how we use most of this information is primarily in the linear pairs that you can find or the vertical angles. Okay, looking at a couple more examples. Here's the figure that I started with. What are the measures of ABD and DBC? Those angles. Well, I obviously can't figure out what the angle measure is if I do not know what the variable is worth. So I need to figure out what kind of a relationship I have. Well, in this case, this is a linear pair. I know that these two angles can add together to be 180 degrees. So that's exactly how I set up my equation. I work my way through it, and I get x equals 19.5. Some people might think that answer looks kind of weird. I did too at first, but then it's odd. It's all a matter of plugging it in and seeing what you end up with. So that's exactly what I did when I plugged it in for x here. 4 times 19.5 plus 39 gives me 117. And then I substituted it in here. 2 times 19.5 plus 24 equals 63. So 117 plus 63 is 180. So it's a reasonable answer. I'm good. If I look at this one, the information that I'm given is that ray FH bisects angle EFG. What is the measure of angle EFG? Well, again, I cannot figure out the measure of these angles if I don't know what the variable is worth. And again, my keyword here was bisect. That means the larger angle was cut into 2 equal parts. So when I look at this, I know that this angle here is congruent to this angle here. And again, in my mind, I'm already thinking, once I see this word bisect, I'm setting two expressions equal to each other, because bisect creates congruent parts. When I work through that, I get 8 to be x. When I substitute that in, 8 plus 2 is 10. 2 times 8 is 16 minus 6 is also 10. And then remember, they just wanted the whole thing, EFG. So obviously this whole angle then is 20. So again, it depends on the information that you're starting with. Here I wasn't actually given any information at all. I just had to know that I had a linear pair, which means I can add the two angles together and set them equal to 180 degrees. Here I was actually given that I had a bisector, so I knew I had two congruent parts, and I could set two expressions equal to each other. Okay. My last example is what to do when you have a little bit more complex of a figure. So again, I'm going to start using what I know to kind of figure all of this out. So I know that if there's a right angle here, There's also a right angle here, so I know that's 90. If this is 43, here are my vertical angles, so I know this is also 43 degrees. If I knew this is 90 and this part of it is 43, then this part of it has to be 47. Because again, it has to equal 90 degrees. Probably what my eye is going to catch is either this straight line here or this straight line here. Either way, I know the full straight angle is 180 degrees. So if this part is 43, 180 minus 43 is 137. Again, I could check this if I wanted to by, here is a full circle that should all equal 360 degrees. So I would at least be able to catch if I made a small math error. I always think it's important to label this picture up because it's a lot easier for me to use it if I need it. So angle UYE, I don't have to like hold those numbers in my head. UYE, I just follow the letters, well that's 90. BYL, following the letters, that's 43. LYE, I'm following those letters, so I need all this. That's 137. LYS is this straight angle right here, so it's 180 degrees. LYU is just this part right here, so that's 47 degrees. BYS, that's all this right here, so that's 137 degrees. Again, these were pretty straightforward, but as a general practice, I think it's very helpful to just mark all the angles up before you start to do anything. It'll just be less taxing on your working memory. You won't have to hold those numbers in your head and use it at the same time. Here's a word problem that you probably will come across on MathXL, and for some reason people find it very, very difficult. My problem is an angle is 30 degrees more than 2 times its supplement. What are the two angle measures? This could be a complicated equation to build. I think just one of them because of how you have to represent the idea of a supplement. I think the easier way to do a problem like this is to actually make 2 equations. One equation is based on the relationship, in this case, supplementary. The other equation is based on the information that you're actually going to be given in the problem, because then you can solve the system of equations. The reason why people sometimes have a difficult time with just building one equation is they struggle with how to build it without using 2 different letters. And remember, you can never solve one equation that has 2 different variables, but you can solve a system, which is 2 equations with 2 variables, but they're both the same. So I made my first equation based on the relationship. I know that an angle plus its supplement has to equal 180 degrees. Doesn't matter the degree measure of the angle, that's the relationship. An angle plus its supplement equals 180. The equation that I'm going to build based on the information that I'm given is I'm literally translating this into math. An angle is equals 30 degrees more than 2 times its supplement. Technically, I have to write it in this order because I can't have 30 more than something if I don't have something there first. With addition, the order wouldn't matter. Subtraction, it will. So those phrases more than or less than indicate I have to switch the order a little bit. So this is 30 more than 2 times its supplement. All I do is I kind of substitute in. I had A all by itself here, so I just took this 2s plus 30, substituted in for A. Then I still had a plus s equals 180. So again, I took this whole expression here and substituted it in for this A, because that's what A is worth, so to speak. I solved all that out and I got S to be 50. Well, if S is 50, then A would be 130. and then I just check it again. Well, 130 plus 50 is 180, so at least I have the supplement part. And then the angle is 30 degrees more than 2 times the supplement. Well, 2 times 50 is 100, and then 100 plus 30 is 130. So it again met both conditions. So on this, should you run into it on Math Excel, it's again, build yourself 2 equations, one based on the relationship, and if this said complement, it would really be the same idea, but I might have A plus C equals 90, because complementary relationships, they equal 90 degrees. This other equation I have to build exactly from the information that I'm given, substitute in, solve. So that's it on 1-5. As always, let us know if you have any questions.